Welcome back. We are still on question from the 2015 free response test, question 2, part B. So this states a second random sample of bills was taken that was 4 times the size. So we kind of use as a guesstimate for explanation n as 100. So now we're like, wow, okay, we were not able to detect anything wrong with this program because it got it up in interval. And so we know that if you increase n, you're increasing the power. And what power means is your ability to detect an untruth. And so ultimately, great idea. That's what you do in real life. You're going to up n and you're going to keep going. And you're going to try to root out the truth because you believe this is the truth. This is the hunch. But right now, this is still the accepted truth. So now I'm going to hypothetically increase his sample 4 times as much and see what ends up happening. So in the second sample, 15% of this bills received the discount. So aha, I'm feeling good again because the second sample got 15%. And so whatever 15% of 100 or of 200, or rather 400, so that means my hypothetical study, I ran the test 400 times and still I got 15. And so I'm like, aha, I know it's 15. But again, that's not when you do a confidence interval. You're not changing the H sub O. You're merely deciding whether you reject or fail to reject. So you took a new n that's 4 times as much. Okay. So hypothetically, we're just going to plug in 400 because this helps students understand what actually happens when n increases. So if I go to my formula and I look at my confidence interval, I get a statistic plus or minus the critical value times the standard deviation of the statistic. So I'm using a proportion. So that's the formula I'm using. And so once again, I get 0.15 times 1 minus p, which would be 0.85, all over 400. However, when I did it the last time, I got a confidence interval of plus or minus 6 when I multiplied the critical value. Okay, so this is when n is 4 times as big. So this was after the increase of n. And so let's take a look at what would happen before the increase of n. We still got 15 plus or minus the critical value times the same 15 times the same outcome, but this was over 100 and we took the square root of the whole thing. So this is my margin of error. And notice they told us that the margin of error before we increased it 4 times as much, we know is plus or minus 0.06. So now they're asking me to calculate the new margin of error if I end up increasing n by 4 times as much. So notice what happens here is this value ended up becoming this, and this stuff is the same value. The only thing different is I'm over, instead of being over the square root of 100 in the denominator, I'm over the square root of 400. So the square root of 100 is just being a number over 10, isn't it? And a number over the square root of 400 is just a number over 20. So notice that this is half. 1/20th is half. See how this would be multiplied? 1/10 times 1/2 would be 1/20th. So notice that's actually what they want me thinking through. This is kind of a tough one. So I actually know my new margin of error would be 0.15 plus or minus half the size, 0.03, okay? Because again, look at how that would be divided by another 2. Now let's go ahead, just like we did last time, and create that confidence interval. So it'd be 0.15 plus 3, which would be 18, and minus 3, which would be 0.12, and aha! Notice I got new circumstances. So by increasing the N, it looks like I did detect some good stuff that I was looking for. So it says determine the value of the margin of error based on the second bills that would be used. So I'm actually going to go up here and answer the rest of this question by increasing N by 4 times as much. My new margin of error would be 0.03. Okay, and that's the question they asked. So determine the margin of error by increasing N by 4 times as much. My new margin of error is 0.03. Now let's apply this in C. So question C says, based on the new margin of error we just calculated that was obtained from my second sample, what do you conclude about whether the program is working as intended? So our conclusion is going to be, they didn't tell us what the confidence interval was, but whatever it was, probably 95, we're 95% confident that the interval from 12% to 18% captures the true proportion. And notice 0.2 is not in the interval now, and that's what we've been trying to vet out. So in my conclusion statement, I'm going to say using the margin of error of 0.03, my new sample confidence interval is 0.12 to 0.18% getting the discount. Now I want to put some facts in there, right? So that's the percent of people getting my discount. We do have convincing evidence that the computer program is not working as intended. Because, I got to get my because in there, I'm running out of room, but because 0.2 or 0.20 is not within the interval. Bam! Great job.